Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This video is part 5 on the chapter of rational numbers, where I will solve the problems of exercise 1b, which is about representation of rational numbers on real line. If you have not watched the previous videos, part 1 to part 4, where I discussed about the properties and comparisons of rational numbers and rational numbers in standard form and solve the exercise 1a problems, I highly suggest that you watch those videos also to maintain the continuity of your preparation on the chapter of rational numbers. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, or if you are watching my video for the first time, I strongly request and suggest that you support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video. Okay, so I have the problems of exercise 1b on the left hand side, and on the right hand side I will solve the problems. Now some problems 1 and 2 has multiple parts. I will not solve all of them. I will solve few of them, and I hope you will understand how to solve the rest of the problems. Okay, so these problems are based on representation of rational numbers on the real line or the number line. Okay, the first problem is represent each of the following numbers on the number line. So let's do part 1, which is 1 by 3. Now 1 by 3, as you know, it is a proper fraction and it is a positive rational number, so it will be marked somewhere on the number line to the right hand side of the origin O. So we take the number line, the straight line, we mark the two end points, we arrowhead, which denotes that both the ends will stretch to infinity, and since it's a positive rational number, we will take the origin somewhat towards the left hand side of the straight line. So let's say this be the point origin O, which represents the integer 0. Now if you have seen the previous videos, part 4, you will be familiar of the concepts and the steps of how to represent a rational number on the number line. I discussed 4 cases, where first case was a positive rational number, which is a proper fraction. The second case was a negative rational number, which is less than 1, and third case was a mixed fraction, that is improper fraction, positive rational number, and the fourth case was negative rational number, which is negative of a mixed fraction. So this is a case 1. So I will take a point A on the right hand side of the origin at unit distance 1 from point origin O. So let's say this be the point A, which is at unit distance from the origin O to the right hand side. So definitely the point A will represent the integer 1. Now since over here we can see that P equals to 1 and Q equals to 3. If you consider in the form P by Q, the 1 by 3 is where numerator is 1 and denominator is 3. So what is the procedure for drawing the rational number 1 by 3? We take a point A on the right hand side of origin O at unit distance. Now we divide OA, the segment OA, into 3 equal parts, because the denominator is 3. Let's say we divide OA into 3 equal parts, and we mark the point 3 equal parts. So all these 3 equal parts are 1 by, the distance of these equal parts is 1 by 3. All these distances will be 1 by 3. Now I will the marking which is at distance 1 by 3. Now I will consider, so I have 3 equal parts. I have divided OA into 3 parts because the denominator Q is 3. So I have 3 equal parts, and I will consider one such equal parts, y1, because P is 1. So one such equal parts will be, if I do the marking of one such equal parts, this will be P, because OP is 1/3. So now OP will actually represent the rational number 1/3. So OP is equal to 1/3 and OA is equal to 1. Therefore, P represents point P represents the rational number 1/3. Now, when you will solve these problems in your exam or in the school, definitely you will not mention this, that all these equal segments or equal parts are of length 1/3. You will only do this much, and definitely write the rational number properly below the point that you have located on the number line, which in this problem is the point P. Okay, let's do 2/7. Okay, let me do 2/7 part 2. This is 2/7. So over here we have P equals to 2 and Q equals to 7. Numerator is 2 and denominator is 7. This is also a rational number, positive rational number, and it's a proper fraction. So I have I will draw the number line, the real line. I will mark the origin O, which will represent the number 0, integer 0. I will take the point A. Now since the denominator is Q is 7, I have to approximately show 7 markings, 7 equal divisions. That is the reason I am taking marking the point A at quite a distance, keeping a good distance from the origin O. So this point A on the number line represents the integer 1, because A is at unit distance from the origin O, the right hand side. Now I will divide OA into 7 equal parts, because in the denominator we have 7. So approximately this need not be perfect, but you can do the divisions markings of 7 equal parts approximately. So 1, 2, 3, 4, 5, 6 and 7. Now you will consider, you have divided OA into 7 equal parts. Now you will consider 2 such equal parts, because P is 2. So 2 such equal parts, and if you mark that point, this will be this point P, and hence this will be 2/7. So OP, the distance OP will be 2/7, and of course OA is equal to 1. Okay, let's do let's do 6. Let's do part 6. This is 5 and 5/7. So this is a mixed fraction. This is a positive rational number in the form of mixed fraction. A mixed fraction is an improper fraction. So this is okay. So now, as per the discussion, if you consider this in the form A and B by C, so we have A, which is the whole part of the number 5 and 5/7. A is 5 and B is 5 and C is 7. Now how do we represent this number, rational number, on the number line? So we will take the straight line, number line, and we will draw the endpoints, and we will take the origin O to represent the integer 0. Now remember that we need to take a point B, which will be at 5 unit distance from the origin O. Why 5? Because the whole part A is 5. The whole part A is 5, and also we will have to take another point, let's say E, from the point, let's say if this is point B, this is point B, which is representing the integer 5. Why 5? Why 5 is the whole part of the mixed fraction 5 and 5/7. 5 is the whole part. A is 5. So as per so we have to mark the point B at the distance a units from the origin O, and A in this example is 5. So OB is 5 unit distance. OB is 5. Now we will have to take a point E to the right hand side of B at the unit distance from B, and that BE we have to divide into 7 equal parts, because C, the fraction part, is B by C, and in the fraction the denominator is C, which is in this example is 7. So we have to do 7 equal divisions from BE, where BE is 1. BE is 1. BE is 1. That is, E is at unit distance from B to the right hand side. So B will represent the integer 5 plus 1, that is 6. Now we will have to divide the BE, the segment BE, into 7 equal parts. And if we do that, let's approximately divide BE into 7 equal parts. Let's say 1, 2, 3, 4, 5, 6 and 7. Now we will consider 5 such equal parts. Why 5 such equal parts? Because the fraction part B by C, the numerator is 5, B is 5. So we have to take 5 such equal parts, which will be 1, 2, 3, 4, 5. This point. So you consider you consider the marking of 5 such equal parts as the point P, and the point P will then represent the number, the given rational number, that is 5 and 5 by 7. Why? Because BP is 5 such equal parts, and the length of one equal part is 1 by 7. Why 1 by 7? Because BE was of unit length. BE is 1, and we divided BE into 7 equal parts. So one such equal part will be 1 by 7, and the point P is at a distance from B, which is equal to 5 such equal parts. So which will be 5 into 1 by 7, which is equal to 5 by 7. So OP will be OB plus BP, and OB we already know is 5, and BP is 5 by 7. So this essentially means 5 and 5 by 7. So hence we have marked the rational number 5 and 5 by 7 as the point P on the number line. I hope it is clear. Now any integer, it is very obvious how to represent any integer on the number line. So let's say I am considering 7, which is, even though I know it is super easy, but anyway let's do it. So 8, how do you represent 8, which is an integer on the number line? So you take the number line, you draw the endpoints, you take the somewhere O origin, which will represent the integer 0 or the value 0, and then you take, since it is 8, you take a point, let's say A, you take a point A which will be at 8 unit distance from the origin O, and therefore this A will represent the integer A, and you have to also show the markings that A is at 8 unit distance from O. So you can show the marking in between, like 1, 2, 3, 4, 5, 6, 7 and 8. So you can write this 1, 2, 3, 4, 5, 6 and 7. Okay. So I will not do the rest of the parts of problem number 1. I hope you got the idea, the core concept of how to draw these positive rational numbers, whether it's in the form of mixed fraction or proper fraction. Now let's see how do we represent the negative rational numbers from the problem 2. Let's see how we do minus 3 by 4. Minus 3 by 4. Now 3 by 4 is a rational number which is of the form 3 by 4 is like a fraction which is less than 1, but the actual rational number is negative of minus 3 by 4. So the drawings will be exactly like 3 by 4, but on the left hand side of the origin O. So this be the number line, real line. We draw the endpoints, and since we will have to mark a negative rational number, it is better you mark the origin O towards the right hand side of the straight line. So let's say this be origin O representing the integer 0. Now what we do is we take a point B dash, just like we did for 1 by 3, we took A. It doesn't matter what name you give to the marked points, it could be A, B, C, D, whatever, but it should be in capital. So it is same as 1 by 3, not same as 1 by 3, sorry, we are doing minus 3 by 4, okay. So what we do, we mark the point A dash at unit distance from the origin O to the left hand side. So this point A dash will represent the integer minus 1, since OA dash is equal to 1. A dash is the point A dash is at unit distance from the origin O to the left hand side. So A dash will represent the integer minus 1. Now what do? We divide the segment OA dash into 4 equal parts. Why 4 equal parts? Because we are considering P as 3 and Q is 4. But why I am writing P equals to 3? Because the drawings will be actually based on 3 by 4, but since it's a negative rational number, negative 3 by 4, all the drawings will be to the left hand side. This is the only difference between drawing the 3 by 4 and minus 3 by 4. The whatever drawing you do for 3 by 4, for minus 3 by 4, it will be just opposite to the left hand side of origin. Okay, so now I will divide OA dash into 4 equal parts, because in the denominator Q is 4. So roughly you can say 1, 2, 3 and 4. So now I will mark the point P dash, which will be at distance 3 such equal parts from O. So which will be the first equal part, the marking of the first equal part will be minus 1 by 4. Why minus 1 by 4? Because OA dash, the distance of OA dash is 1, and we have divided OA dash into 4 equal parts. So length of each equal part will be 1 by 4, and since all these markings are to the left hand side of origin O, they all will represent negative numbers. So the first marking of the first equal part from origin O will be minus 1 by 4. Similarly, the second marking will be minus 2 by 4. The third marking will be minus 3 by 4, and hence the marking which is for minus 3 by 4 is the point required point P dash. So P dash is representing the rational number minus 3 by 4. Okay, let's do, you can obviously do the negative integers like minus 3. Let's do one more, that is 8. Let's do part 8, which is minus 2 7 by 7 by 8, minus 2 and 7 by 8. Okay, so for reference, it is better that you write down what is the whole part. Whole part is 2, and the fraction part, the numerator P is 7, and the denominator, not P, we were using. It is better while we solving the problem, it is better we use notations as per our theoretical discussion. So in the theoretical discussion, I used B, and C is 8. So basically, if we consider this in the form of minus A and B by C, so A is equal to 2, B is equal to 7, and C is equal to 8. Okay, now how do we mark this rational number, negative rational number, on the number line? So what do? We draw the number line, we mark the draw the arrowheads, and since we will have to draw a negative rational number, it is better you take the origin towards the right hand side. So let's say this be the origin, which represents the number integer 0. Okay, so first what we do, we take the point B dash, we take the point B dash, which will be at unit distance OB dash, which will be at a distance of 2 units from origin O. So OB dash will be 2. Why 2? Because the whole part in the given rational number, which is a mixed fraction minus 2 and 7 by 8, the whole part is 2. That is why we will have to first mark the point B dash on the number line, which is at distance 2 from the origin O on the towards the left hand side. So B dash definitely will represent the integer minus 2. Now we will have to take a point, let's say E dash, at a unit distance from B dash to the left hand side. So then this E dash will represent the integer minus 3. Why minus 3? Because B E dash is the distance of the segment B dash E dash is 1, and the B dash is representing the point, the number, rational number of the integer minus 2. So that's why E dash will represent the number minus 2 minus 1, because when we go to the left hand side of the origin O, the number decreases, it becomes more negative. So E dash is minus 2 minus 1, which is minus 3. Now we will divide B dash E dash, the segment B dash E dash, into 8 equal parts. Why 8? Because in the given mixed fraction, the fraction part, the denominator is 8, C is 8. So we will divide B dash E dash into 8 equal parts roughly. So 1, 2, 3, 4, 5, 6, 7 and 8. We have divided B dash E dash into 8 equal parts, and now we will consider 7 such equal parts. We will consider the marking which represents 7 such equal parts from B dash to the left hand side. So 1, 2, 3, 4, 5, 6. Now 1, 2, 3, 4, 5, 6, 7. So this is P dash. This marking represents P dash, and this will be the P dash will represent the rational number minus 2, 7 by 8. Why the point P dash is representing the rational number minus 2 and 7 by 8? Let's try to understand that. So what we did, P dash, B dash, P dash, B dash, B dash E dash is 1. We divided B dash E dash into 8 equal parts. 8 equal parts. So each part, so as you can understand over here, as per the drawing, E dash P dash is equal to 1 by 8. We divided B dash E dash into 8 equal parts, and we considered 7 such equal parts. We considered the marking which is whose distance from B dash is 7 such equal parts, and which that marking is the point P dash. So B dash P dash, the distance of B dash P dash is equal to 7 such equal parts, which is 7 into 1 by 8. This is 7 by 8. Okay. Now what will be OP dash? What will be OP dash? OP dash will be OB dash plus B dash P dash, which is equal to OB dash is 2. OB dash is not minus 2. Please remember, please don't make this mistake. OB dash is the distance between the points O and B dash, and distance between 2 points is always positive. So OB dash is 2 and B dash P dash is 7 by 8. So this is 2 plus 7 by 8, which is equal to 2 and 7 by 8. But since the point P dash is on the left hand side of the origin O, if we can say that P dash represents the rational number minus 2 and 7 by 8. Okay. So I will not do any other parts of the problem number 2. I hope the concept is clear, and you can use the concept to do the rest parts of the problem 2. Okay. Now let's do problem number 3, which are true and false. It says that minus 3 by 5 lies to the left of 0 on the number line. Minus 3 by 5, minus 3 by 5 is a negative rational number. This implies minus 3 by 5 will be less than 0. We have learned in part 4 that regarding the positive rational numbers and the negative rational numbers, or we know that all positive rational numbers are greater than 0 and all negative rational numbers are less than 0. So minus 3 by 5 is a negative rational number, so it will be less than 0. And we also know that any number less than 0 is always marked on the number line to the left hand side of origin O, and any number which is positive, they are all marked on the right hand side of the origin O on the number line. So part 1 says that minus 3 by 5 lies to the left of 0 on the number line, which is true. Since minus 3 by 5 is definitely less than 0, and any number less than 0 is marked to the left hand side of origin O on the number line. Okay. Part 2, minus 12 by 7 lies to the right of 0 on the number line. This is obviously false, as minus 12 by 7 is less than 0. The reasoning you can write like this, as minus 12 by 7 is less than 0. So it's a false statement. Part 3 says the rational numbers 1 by 3 and minus 5 by 2 are on opposite sides of 0 on the number line. This is true. Why? 1 by 3 greater than 0 implies 1 by 3 lies on the right hand side of origin O, whereas minus 5 by 2 is less than 0. This implies minus 5 by 2 lies on the left hand side of origin O. And since if a number lies, if we have a number, if we have two numbers, let's say this is the number line, we have the origin O which represents the value 0, and we have a number A, let's say on the right hand side, any positive number, and we have another number A dash which is less than 0, will be on the left hand side of the origin O. So definitely A dash and A are on the opposite sides of the origin O on the number line. So part 3 is true. So this is true. Part 3 is true. Part 3 is true. Okay. Part 4. The rational number minus 18 by minus 13 lies to the left of 0 on the number line. Now minus 18 by, whenever you deal with any rational number, you always first convert it into standard form. So minus 18 by minus 13 is not in standard form, as the denominator is negative. To make it positive, to make the denominator positive, we multiply both the numerator and the denominator with minus 1, because we know that any rational number remains the same when we multiply both the numerator and the denominator with some non-zero integer. So when we do this, it becomes 18 by 13. So this is a positive rational number. This implies 18 by 13 lies to the right hand side of origin O. Therefore, this statement is false, as it is saying the rational number minus 18 by minus 13 lies to the left of 0 on the number line. So, it's a false statement. So, this was all. It was barely 3 questions for exercise 1B, just based on the representation of rational numbers on the number line. So, even though I did not solve all the problems, I hope the problems I solved, this will give you enough understanding of the concepts of representing rational numbers on the number line. So, basically there are 4 cases. One is the rational number, which is like a proper fraction less than 1, positive rational number. The second one is the same negative rational number, and which is a negative of a fraction, that is ignoring the sign, the rational number is less than 1, but it is a negative rational number. Case 3 is a mixed fraction, that is it is an improper fraction greater than 0, greater than 1, but it is a positive rational number. And the last case is the negative of a mixed fraction, that is a number which has the whole part and a fraction part, but the total rational number is negative. So, these are the 4 cases. If you have watched the part 4, the previous video, you will understand pretty well how to represent any given rational number on the number line. Just remember one thing, that if you are given an improper rational number, let's say you are asked to mark a rational number, let's say 21 by, let's say not 7, let's say 24 by 7. You have to mark this point, you have to represent this rational number on the number line. Since it's an improper fraction, because the numerator is greater than the denominator, you first convert it into a mixed fraction. This will be 3 and 3 by 7. So, now you have the whole part, this is A, and the fraction part, the fraction part. So, this is B and this is C. If we consider this in the form A and B by C, A is 3, B is 3 and C is 7. So, then now based on A, B and C, you know how to represent this rational number on the number line. If you have watched my previous video, or I have solved this kind of problems in this video only, you will be able to represent this rational number on the number line. So, that is all for today's video. I hope this video was beneficial. If it is, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. The next video will be on addition of rational numbers and its properties, and then we will solve the next exercise, which is 1C, which is based on in the next video we will study addition and subtraction of rational numbers and their properties. And the next exercise 1C, I guess, is based on the addition and subtraction of rational numbers and their properties, that is properties of addition and subtraction operation on rational numbers. So, please stay tuned for the next video, and thanks for watching, and until the next video, take care and bye.